Hi, welcome to the May 3rd meeting of the CNCF IoT Edge Working Group. On today's agenda, I put a number of very brief things that are more in the recap interesting item territory, but as always, group members are free to late add anything that you like. If we don't get time for it this meeting, we'll just carry it on to the next. Also, if we run out of agenda items, we'll just go into free form, birds of a feather, open forum discussion on whatever members are interested in chatting about. You're free to bring up questions or anything interesting in the field of IoT and Edge that you've come across in the last few weeks. Let me quickly go over the things that I added into there. The first one is that the Eclipse Foundation sponsors 50 plus edge-related open source projects, and they have been hosting an annual survey of IoT and Edge commercial adoption and developer usage. So that survey recently opened, and there's a link in the agenda notes doc, but let me put it in the chat as well. So they welcome your participation. That's been running, I think, just short of 300 people participating in that survey last year, if I'm not mistaken. So in terms of how these things go, I think it's a reasonably decent source of information on trends in the IoT Edge space. You can go back and find last year's survey, but they're getting this year's started. And as you answer the questions at the very end, you have the option of providing an email to get notified of the results when they tally them. Second item, KubeCon China is going to be held in Shanghai in September. It's interesting that they just announced this recently and slipped it in before KubeCon North America. The CFPs are open right now. I believe they're open until July 18, but you better check on that. When they've done China in the past, also for the rest of the world, they often close the nominations at midnight Pacific time in the US, but in China, they base it on whatever the calendar runs there. So depending on where you live, it could be even a full day off from where you are. So keep that in mind. If you're interested in doing a CFP there, you check what time zone and reference points they're using for the CFP if you're the typical procrastinator and are going to push the envelope on how late you submit. There is a networking edge and telco track available there. Then in the agenda notes, I also put a link to the KubeCon North America event. That's going to be November 6 through 9 in Chicago. That's also currently open for CFPs. I think that one is open until June 18th, so it's open for a little more than a month. And also they have the same networking edge and telco track available. I've been informed that there will be another Kubernetes on the Edge Day event, or at least they are recruiting volunteers to help organize it. So I think that's going to take place, but for now, CFPs aren't open and they haven't announced a day or any details, but I believe it's likely to happen. And I hope so, because that event in Europe, I thought, went very well. I mentioned at our last meeting, which we had a brief recap of what went on at KubeCon Europe, and I mentioned that there was a presentation on a new satellite feature for the Harbor registry, which is a container image and Helm chart registry. This satellite feature is made for edge locations that are either air-gapped or intermittently connected. And they posted a YouTube video that covers this. The link I just dropped in the chat has a time index to skip ahead to the part on the satellite feature, which was only, it was a hour-long presentation on Harbor in general, but this jumps to the spot where they talk about the satellite feature. So I have a feeling that people operating in the edge community might be interested in that. Finally, an interesting item I just came across in the past day is I've become interested in the opportunity for AI and machine learning at edge. And there is an org called TinyML that is pursuing machine learning at edge. And I found that they're hosting a hackathon that is, I think, partially based on the city of San Jose smart cities, but it's a hackathon that challenges you to come up with AI apps that use image recognition to count pedestrians in crosswalks. And they have cash prizes. Sounded kind of interesting. It looks like the nominations started a few weeks ago, but it isn't clear what the deadline was when I looked. I just glanced over it, but looked like kind of an interesting project. And I'm convinced that this whole field of AI at edge is just wide open at this stage, but it's going to be huge. You know, the world got an awakening by the popularity of ChatGPT, which is text in cloud. But the fact is that most of the world's data originates at edge. And I think the opportunity for using AI and ML is actually bigger at edge than it is with text processing based on chat. We'll see what happens. But like I say, this thing is something I found interesting. With that said, that runs out of the things that were submitted formally as agenda items. If anybody else wants to bring up something, go for it. Anything you've come across interesting, or questions, observations, suggested discussion topics.
Hey, Steve, just as a note, I meant to watch that Harbor video and did not get a chance. Thanks for putting it back up. And secondly, we put in an RFP for KCP Edge for KubeCon North America. I just put it in yesterday, and KubeCon China as well.
That sounds good. If you want to give us an update on anything, I missed the last community meeting for KCP Edge, but if you want to give us a brief update on anything new that's been happening there.
Yeah, I can keep it brief actually for you.
And maybe give a summary, because I think we have people who might not even know what it is. Just, you can spend 60 seconds just recapping what KCP Edge is about.
Yeah, so we've built KCP Edge with our sister technology KCP community, and the real gist of it is to try and give people the ability to have a one-to-many relationship with edge locations, so to be able to deploy workloads to many different devices without being encumbered with having to handpick or manually recraft each time you wanted to put a YAML and select and put it out to some match label, etc. So that's the main gist of it. We were originally achieving that using KCP, but we've now moved past KCP. KCP is now they're looking for new suitors there. Red Hat is no longer going to be backing that project as the maintainer. So I don't have any update there as to how that project's coming along. But we've moved our attention to other Kubernetes distributions, and we feel that we can do the same type of work with any Kubernetes distribution. So that's going to be pretty cool. If you're interested in learning more about it, kcp-edge.io is the location, and our YouTube channel is at kcp-edge. I'll just put that in the notes there.
Now, you tickled my interest with that comment that, about Red Hat maybe reducing the contribution level to the parent KCP. How strongly is KCP Edge tied to KCP itself? Do you share components, or is it just kind of a fork with an associated mission that is largely independent.
Yeah, so at this point, we are using it for the next month or two. We'll be using KCP componentry underneath the covers, but we are moving away from it to something more generic. So for the next 2 months, we have an exposure, but we're moving past it because we see value in other Kubernetes distributions.
Now, in terms of architecture, when you attach to Kubernetes distributions, based on the way KCP Edge works, could you actually even go at sort of, I call it like, I don't know, if it were all public cloud, and I realize Edge isn't, they call it multi-cloud when you deal with Kubernetes on, say, AWS versus Azure versus GCP. Could you conceivably use KCP Edge in its current form to manage edge nodes running different distros of Kubernetes simultaneously, like say microK8s, K3s, and you don't have a uniform footprint out there in the world for whatever reason?
Right. So there's two areas where the different Kubernetes distros come into play. So first is delivering or deploying a workload to a given distro. That we can do today. So anything that speaks Kubernetes, we can deploy to at this point. Then there's the underlying API machinery. And today we use, for the next few weeks, we're going to be using KCP. But we're looking to make connectors that will work across any Kubernetes distribution using something we call a denatured view. So that allows us to deploy a workload to a Kubernetes distribution and not have it necessarily be applied there. So what does that mean? So if you take a deployment, a pod, you take a config map, a secret, and you apply it to any given namespace in a Kubernetes distro, it activates, it deploys, it creates a pod, it can use those resources. What we're creating is what we call denatured views, whereby you can deploy or apply a Kubernetes resource to a namespace and nothing happens. And why is that important? Well, it's important because when you want to transport things across different Kubernetes clusters to get to the eventual edge location, you don't want them to apply immediately in the intermediary layer. So this is where we think the power of what we're experimenting with gets us into hierarchical distribution of workloads at a much faster pace. And I think it's going to become, I think people will catch on to how this works quite quickly and start to leverage it in other projects fairly soon.
That sounds like an interesting concept. So let me just make sure I have had this straight. You could maybe run a top tier control plane in a public cloud, talk to, I'll call them mezzanine Kubernetes control planes in metro areas. Like, let's just say you put one in America East, another in America West, one in Europe. And then they in turn go down another tier to talk to edge locations running, really kind of tiny reduced resource Kubernetes clusters. And you're saying you could take this, you could bubble this down from the top tier to the regional level. They don't really act on it other than sort of pass through, maybe tolerating intermittent connectivity even to the lower level and acting as a caching or CDN-like layer that multiplexes out to large numbers of edge nodes. Then they get to the edge node and kind of this distilled, dehydrated spec gets, you pour water on it, it grows and expands and actually takes root. So do I have that right?
Yeah,
if
you
so,
got
it sounds really cool.
Yeah, so we call, that mezzanine level, we call an intermediary at the moment. We use the term denature for the most part, but inert is another one that comes up. Dehydrated is another term that you can be used to characterize it. And then when it finally gets to its final resting place where it's intended to be deployed and manifests itself as a pod or a config map or a secret, that is the spot where we rehydrate, if you will, right? Or create or allow the workload to run. And so it's really, it's great because now you have a 2+ tiering, 3+ tiering effect, not just hub and spoke. And it allows you to move workloads around, as you mentioned, to regional areas, or even places where you might have, not regional clouds. What do they call those things? Sovereign clouds as well, right? So you might actually look for places where you can do that, so that the workload, will bounce through there, will be applied through there, but will not necessarily take effect. And you can think of this as, if you change the API or the type of object, let's say from deployment to deployment dot denatured, you could get that effect, right, in that intermediary level, because there is no controller that knows how to react or respond to or apply something that has that extension. And then once you get it to its final spot where it needs to be rehydrated, you remove the, let's say, the dot denatured off the end of the object type, and then it will apply correctly because the controller could absorb and apply it.
And you're saying this just uses kind of generic Kubernetes primitives, so it's not tied to a particular distro.
Yeah, so that
you
was
should
the
be
thing.
able to use like a heterogeneous configuration where you don't have the same Kubernetes distro at all layers or at all edge leaf nodes.
Right. So KCP created something that did something similar, had some similar effect. And then we took it and made it into something, KCP Edge, we took it and made it into something that's a bit more generic. And that's what we're in the process of building now.
Kate, I see your hand raised, but I'm going to jump in and hog the podium just for one more question, because I just can't resist. But how generic is the transport plugin as it goes through these layers and out to the leaf nodes? Does your project implement and prescribe a particular transport, or is this a plug-in mechanism where you could write your own? The reason I ask is there's, particularly when you get to these edge leaf nodes, there's obviously the common scenario of intermittent connectivity, but there's even some like air-gapped where
Right.
I've heard of agricultural use cases, for example, where there is literally no network connectivity, wireless or otherwise, unless somebody goes there. Could you have a transport like package this up in a USB key or package it up onto a cell phone that acts as a Wi-Fi access point when somebody goes out to this remote node, something as crazy as that?
Yeah, so I saw, that comment, you made a comment along those lines last week and about ag. And I thought it was fairly interesting. And we have we're doing a joint studies agreement with the folks in Cornell right now on agriculture. And it's something that we're going to experiment with, because you're right. When you get to these remote locations, you may only have passing connectivity, right? Or maybe I think somebody used the analogy, if it was you last week, about somebody putting a thumb drive or a phone in their backpack.
Yeah, that was
driving
me.
through town, and unbeknownst to them, or no action required by them, they went ahead and transmitted data upstream. So that's very interesting for us. I think in equitable distribution, I'd like to explore that use case some more. So yeah, we are going to look closer at that. Today, I don't have that on the truck, but the community is looking at that. And the facility for synchronizing the workloads to the edge location is something we call the KCP Edge Syncer, and it's detailed in that Medium blog post that I just put in the chat.
Okay, thanks.
Yes, Kate.
So I was also curious with this. I just had other questions, and you mentioned how this is a way of it was denatured, the word you used for, okay, of getting that deployment to the farthest spoke or the desired spoke. I'm curious, how strong is the hub in this scenario? Because I think the counterpoint to this would be that the control plane knows how to directly deploy to that farthest spoke that you're trying to target. So is the hub applying this deployment to everything because it knows all these nodes and clusters, or is it only aware of that first layer and then the second layer is doing the applying?
Yeah, so at the top layer, it's aware of the inventory, so to speak, right? So it knows where the location is and how to address it. And so then it goes through the filtration process of using selectors and labels to determine which edge location to exactly put it. So in the intermediary layer, you could add more smarts there to put another a set of inventory there as well. But I see that less, probably less so a popular option. I see it more so being more of a, you know, a main hub, like a smart hub, so to speak, right? That has all those smarts. Good question. Thank you. Does that help answer?
Yeah, and I think the node selectors part was definitely something I was curious about, how that was being involved and kind of when the operator kicks off the decision to undenature it and at what point that happens. So that makes sense that node selectors are involved.
Cool.
Mark, I see you have your hand raised.
Yeah, so this is interesting, Andy. I think it sort of brings to mind what we do with long range networks like LoRa and pre like Istio mesh networks, really pushing data across nodes. There is no, it's not a multi-tiered model so much, but it might be interesting for your team or the community to look into. Essentially, every node connects with other nodes. It creates a peer group, and through that peer group, you can then forward data or messages to other nodes. Eventually, some node knows what to do with the data. So in this case, a node would need to know, hey, I need to rehydrate this thing and actually run it. But you in that mesh network, you can actually basically set it up so that you could query nodes for like who are your peers, like how close can you get me to my final destination, and you'd need almost like a control plane element that then says, send it down this path. But the nice thing about the mesh network in this scenario also is that because of the multi-node connectivity, because each node connects to multiple peers, if a node goes out, you have multiple paths to that final endpoint that you're trying to get to. But yeah, it's interesting to see this pulled into the Kubernetes, and of course mesh networking's really been overtaken by other things in this space. But if we can set that aside for a minute and look at how it was done, on microcontrollers in the past, it's interesting.
Yeah, I didn't think of
old
that,
is
but
new
that would
again,
be a
right?
really cool concept. LoRa might be a little low bandwidth given the payloads of those packets for doing very much in terms of a spec, but mesh in general, maybe you could even use like, Wi-Fi or something to move through a metro area. And there are techniques. There was an old thing used for control telemetry called the ricochet network, where every node was aware of its latitude and longitude, and you would tag a destination with that. And somebody that heard a packet with a target destination that was where they knew they were closer to that destination than the sender would take it and try to forward it. And it was pretty resilient. The patents, I think, have long expired on that, but one could build something like that, I think, out of existing tooling. Whether there's an open source project that might already have it, that might be the case, but I'm not aware of it.
I mentioned a lot of those concepts are in OpenZT, which I was presenting last week, operating as a smart routing mesh network. So you can effectively, because we don't even route traffic on IP and DNS, you route it according to the identity. You just say, hey, I want to send this to the node that's at that far end, and for it to come back to life or shrink back down, and the overlay will just handle all of that, for you magically.
Does OpenZT have awareness of physical locations of nodes, or do they base it on signal strength, or how does,
it does?
How does the
So
routing work?
All of the nodes are communicating to one another, and the control plane is facilitating that information as to what is the latency between each hop. So when it says I want to send something from a source to destination, it's effectively running a Dijkstra's algorithm to go, well, the lowest latency way is to go across all of these hops which are available.
Yeah, so, Andy, it almost sounds like a plug-in architecture for the transport would be, you don't want to tie it to anything too specific. And the fact is that if one were to do a plug-in architecture, The cool thing to do would be not just to use it for control plane, although I'm a firm believer in isolating control plane from data plane. But when you, at the end of the day, a lot of these apps that you're running, these containerized apps that are going to run at the edge leaf nodes, are going to have demands to talk to one another as well. So, having in place some sort of a mesh architecture for that would be highly desirable. And maybe also calling for a plugin. But if you really wanted to amp this up and do the world a service, having this plugin be versatile enough that you could earmark, one level of this for control plane, meaning higher priority than the data plane, that would be really taking the dial up to 11, because things fall apart when the data plane can hog all the bandwidth, so the control plane no longer works. And
I'm not sure we've implemented that, but we have had that discussion before when talking to automotive companies. So you could effectively say, well, it's, for a telco, it's like, if it's VoIP or entertainment, don't care. Critical systems need to make sure they have the priority, and the overlay can force that to take.
QoS. Yeah.
Correct. Yeah, exactly.
Yeah, I think it would be worthwhile maybe having a discussion, Philip, with you about OpenCT, and maybe there's some area where we can interact with KCP Edge, figure out if there's a way to show that off. How the two of us can work together to make control plane more resilient across transport.
Yes, and you threw it into the window. That's good, because I actually need to jump onto a call, which is a perfect forum to discuss this with some of the developers. So I will get back to you.
Great. See you again next time.
Thanks for coming, Phil.
Yeah. Thanks,
Shannon,
guys.
did you have your hand up?
Yeah, I was just curious about the whole thing, especially when it comes to like air gap environments. I was quite curious about what's the opinion of the people around here in this meeting, because I get to work with air gap environments almost on regular basis, because let's be honest, SMEs and big infrastructure, big companies like oil and gas, they don't really like. Some of them are very skeptical about connecting their edge devices directly to a public cloud or something. And what my understanding is, it like at least the containerization part of the solution sometimes is not the best thing when it comes to air-gapped environments, right? Like I had to work with someone where they have a backlink channel to some certain control entities where it's just 5 Mbps per second, and they wanted to, it's everybody still jumping on the whole containerization aspect of software development, right? So they have containers which are let's say a couple of 100 megabytes here and there, and sometimes when you want to, let's say, update the container on certain edge nodes which are not very healthily connected to the internet, it becomes much more of a tricky situation to get updated containers on these kind of edge networks. And when I say edge networks, these are extremely far edge. Like some of them are just absurdly out there on their own, but somehow they have a small backlink that gets connected to a central entity, and then that somehow is meant to be used not just for updates, but also for data that is being sent upstream. So it's quite an interesting challenge actually when it comes to working with these kind of air-gapped environments.
Yeah, so like we've heard this before with like cruise ships, oil rigs, etc.
Right.
So energy, entertainment, travel. Yeah, so these are all important areas to include that we have not yet delved into.
Yeah. But also adding to Marx's point, sorry, Steve, just a second, but is the fact that I think the discussion that goes on when it comes to the mesh networking stuff, have you guys heard of this IEEE standard for low power networks? So it's an IEEE standard called 802.15.4, and these guys focus solely on extremely low powered networks. But the plus side of it is they have some really nice protocols. So I wrote my master thesis by picking one of these routing protocols, or let's call it back off protocols, and it actually works wonders when you think about it. It's so simply designed because these kind of networks anyways have to sleep more and do less, and when they have to do something, they have to do a lot. But some of the protocols are insanely good, and I was quite curious if someone in the Kubernetes community stumbles on such protocol and starts implementing some completely cut off protocol, which is like a back off mechanism. They have very nice features with IPv6, so you can do a lot of interconnecting nodes. You can design shortest routes when a certain set of subnetwork devices go down, and also it's quite nice if you guys want to have a look into it.
Yeah, I kind of think that the Kubernetes project would steer away from dealing with protocols directly, because right now I believe they kick that down to the Linux kernel host, you know, going through the container runtime even. They did have a major reformation of Kubernetes to deal with IPv4 and IPv6, but even there, I don't think anything going on in the Kubernetes project tries to go below that waterline. They try to keep the abstraction layers a little simpler than that. But that's not to say it wouldn't work with these protocols. Mark, you've got your hand up.
Yeah, so I guess one of the challenges that I see is that I'll use retail as an example, is that so retailers have thousands of sites that they deploy to, and if they have Kubernetes deployed into those sites, you end up with this hub and spoke model where not only do the retail sites not talk to each other, that they have intermittent connectivity to some centralized hub, and they sort of allow it because if they're using Kubernetes, that's the way it needs to work that way. The challenge that we run into, and that I kind of look to this group for ideas about, is that with the hub and spoke model, you can really overwhelm the API server when thousands of sites check in, all just trying to maybe get an update or something, but they're all trying to communicate with the API server at the same time, and it just overloads the system. And so, I've been toying with some ideas about buffering communication and sort of, in the vein of eventually consistent data, sort of eventually consistent communication, where if they're just checking in to get an update, do they really need it immediately? Maybe they do. Is there a way to build sort of queues that are, where you could say, I really need this now, versus like, I need an update in the next 3 hours, or, so I think this is a problem that we're all going to be facing for Edge. And that's why I suspect, Andy, why you guys are looking at a not hub and spoke model. But that particular solution doesn't work for the retailers that we've got, because they won't let each retailer talk to each other. So we can't pass data between stores. We have to go through some central location. So, just really interesting challenges.
Am I wrong, Andy? It sounded like that mezzanine architecture would be a way to cut the fan out from the top tier.
Yeah, so I was just about to jump in here, but I wanted to wait for an opportunity, right? So, Mark, exactly where you're double clicking there is exactly where we're going next. We've got working on our next proof of concept for September, where we'll be doing work on scalability. And one of the things, two of the things that come up consistently for us, right, is that these etcd clusters get overwhelmed with a few more than a few thousand objects, right? So that's first. So just to go a little bit further with that, is that's one of the reasons why KCP Edge, we've chosen not to go with any kind of bundling. It's the raw data types themselves, right? The raw API types. So deployments, config specs, et cetera. We're not using bundles of any sort, right? No manifests. The second thing then you hit, though, right after you get past that hurdle, and we've done tests to prove this, is the API machinery. So we've actually got work that we did and we submitted to upstream where we do API priority and fairness. So we've made corrections to that algorithm to help in this case. So we're ready for that, but we have to get past the object store limitations, and we're working on that next.
I see.
Yeah, I was going to say when you mentioned the API server, Mark, whether you really meant the API server or etcd, because etcd is kind of notorious. They knew from the get-go that it was
Yeah.
architected, I think, for 5,000 cluster
Yeah.
nodes.
Mhm.
And even then, when you say 5,000 cluster nodes, to even get to that level, it requires heroic efforts. I mean,
Yeah.
that isn't like a tiny 3-node etcd cluster. You're going to have to invest a lot of resources to feeding a monster, basically, to keep up with a 5,000 node cluster. And it wasn't that there's something magical about clusters either. I suspect it's objects in general, that if you have large numbers of objects of any type, whether clusters or not, the etcd backend is going to be challenged. If you could tier this, that might be a solution, but it's interesting to hear that maybe, Andy, you've done research and figured out that even if you magically made the etcd issue go to nothing, that the API server would just be a bottleneck that wouldn't be too much further behind it.
Yeah, so we did work on the API server part because that was it was more low-hanging fruit, so to speak. But I like your idea about buffering. It's an interesting one. I mean, eventual consistency of any implementation would be. I'll got to get you. I'll look you up and figure out how I can get you a link to the KEP that was for associated with the API priority and fairness. Maybe you can take a look at that. There might be some ideas and generated out of that. But yeah, as you say, like, but get past the limitations of time and space, right? Because Steve, like, not every object is created the same. There's different objects of different sizes as well, right?
Yeah.
They're not all exactly the same size. But get past time and space. Look in the back pocket of AWS or any other hyperscaler, right? They're looking to charge you for your instances. So if you have a 3-node etcd cluster, right, on a RAF protocol, and then you do that 100 times, well, we blew up our budget. We came up to the conclusion that if we wanted to get to 1 million edge locations, we'd be spending on the order for each instance of putting out 1 million edge locations, roughly about 360,000 a year in just the compute cost and most of that was to host the object store. It was a 20x increase over what we could have done with tin cans and baling wire.
And
right?
that is just like the compute cost, Andy, right? Not like the egress.
The
other advantage
egress.
I can see of having this tiered architecture of get it down to the metro area, maybe depending on the deal you cut with hosting, you're not going to get gouged so much on network egress costs either.
Yeah, this wasn't even approaching multi-cloud. So if you got to multi-cloud, the egress ingress would probably be 1 or 2 times more than that alone. Yeah.
So Shan, back to your original comment about how you deal with air gapped and nervousness, rightfully so, about connectivity to the internet. I think maybe something my personal opinion, it's underutilized, is this concept of using, non-network transport. Like, there was kind of a half ingest RFP somebody wrote about the bandwidth of strapping SD-RAM cards to the legs of carrier pigeons being higher in bandwidth than fiber connections. And, the fact is that some of what goes on to these edge locations, like delivering updated container images, doesn't really have to happen, on real-time latencies. Yeah, you would like to update them right away, but the realistic attitudes by people who are running at those edge nodes is that they would like to do those updates when production is shut down. They're not going to go disrupt a working refinery at 1 p.m. in the afternoon during peak productivity to update all their containers. That would probably be lunacy. So the bottom line is that there is a lot of this traffic that if you could get it there by, flash drives sent by FedEx, or in rural ag areas, just somebody who takes it out there on a motorcycle, that would be perfectly workable for a lot of these use cases. Even going back the other direction, I think a common thing that's going to happen if ML takes root at edge, like I think it will, there will be demand to run inference engines on live data. But looking ahead a couple moves on the chessboard, you have to keep those trained and optimized. So every month or two, maybe you want to retrain and take advantage of new data. Well, that requires collecting training data from potentially 100,000 nodes out at leaf nodes. Do you have the bandwidth to send that live? No. Do you even need it live or want it live? No. Well, what if those things, 4K cameras or audio sensors or whatever you've got, could sidebar retain this historical data to flash drives, maybe encrypt it and sign it so you know it's authentic. And then somebody collects these flash drives once every week or once a month and sends it physically to be ingested by a public cloud where you would run your retraining exercises. That should be perfectly viable. And it probably would save a whole lot of money. I mean, even delivering from cloud to edge, it might be a way to get around egress costs. Sending it back up to the cloud might be a way to deal with no or intermittent connectivity. So I think that you want to keep an open mind about ways to deal with reasonable desires to not connect to the internet, maybe ever, and buffering things to physical storage that are physically transported would seem to be a way to do this, that there's no reason it shouldn't work. You do want to have security on this, but I think that's a solved problem. I mean, obviously, if you're going to FedEx this data and it's sensitive, you need to worry about that being lost or stolen. You don't want to be somebody who gets fired because, a bunch of customer records got lost and and it makes the news. But if you record it to some physical device and it's encrypted, I don't know, with 60 gazillion bits of of an encryption key,
Quantum safe.
That should be pretty solid.
Yep, I think that Steve, you just summarized the complete business strategy of the product that I'm working on. So we took the other way around. When I started with the company where I am right now, they actually they actually were shipping products based on where you would put in a USB stick and things would get updated, this and that, because that generally was the criteria or the requirement for a lot of customers who generally are very air-gapped or decide to have very air-gapped networks. So, and it's only because of recent trends that some of them are now slowly and steadily coming out of this rabbit hole of, oh, guess what? Maybe there might be a benefit of having certain updates over the air, in the sense that some part of the network would be connected to the internet to keep certain things up to date or be compliant with certain security requirements and this and that. So I mean, we might be laughing, but guys, this is what I have to do more on a daily basis, is trying to train my pigeons so that they could ship the SD-RAMs to the edges, right?
Yeah, and there are things to worry about. I'm an old enough guy. I remember stories back, delivering those things out to edge is just like delivering to on-prem, where the hackers will discover it and try to hack into that. And I've heard of stories of things like mainframe tapes being fake, where, in the old days, mainframe OS vendors would literally send mag tapes that had the updates, and they'd come with packaging that had the vendor's labels. And there are rumors that somebody stole the boxes, put a fake tape, and the usual behavior of the operator was they'd mount the tape and run it without, the authentication would just be that it arrived by UPS and the box looked authentic. And that's a recipe for a disaster. So I think that when you send it out to the edge nodes, it needs to be signed, it needs to be encrypted and authenticated more than just the package looks legit. And even with USB keys, I would not recommend that people would mount a random USB key, because there are all kinds of hacks with those where they could have a keylogger in this key, even if the actual key had authentic signed data. It's almost like you need kind of a mezzanine device that is a DMZ to ingest this inbound data and not route through USB signaling, which is potentially far more than just data. Maybe another form of storage other than USB would be more desirable, like an SD-RAM card, because you wouldn't expect the system to tolerate an SD-RAM card is incapable of reporting that it's a keyboard, for example. Andy, you've got your hand.
Yeah, Steve, just on that note, I'm heading up to Vancouver for GitOpsCon. I'm presenting there next week. And one of the things that I thought was interesting is my company required me to get a loaner laptop this time around to travel internationally. Apparently, there are people confiscating laptops. You have to either log into them, let them see what's on it, and then they'll install spyware or keyloggers, et cetera, et cetera. So they don't want to take that chance anymore. So they're actually distributing loaner laptops for anybody traveling internationally, no matter where the destination is.
First time I've heard of that, and no matter what the destination, but I've certainly heard of certain places that I won't call out the name of because of politics.
They're not discriminating anymore. They're just saying it's anywhere.
Yeah, they have a pool of out of warranty laptops, give it to you, and then you come back and they literally like grind it up, because people could have mounted chips there in the thing if if you weren't in custody of it 24/7. We've got 10 minutes left. If anybody's got wants to continue on this discussion topic or any other one.
Looks like Victor's got his hand up.
Yeah, the comment. There's a lot of good discussion here. I actually has been reviewing that Edge native white paper. So I think it'd be great to capture the discussion here and kind of a continuation of that, what's covered in that white paper. Like, for example, how to classify edge, right? Far edge, remote edge. What is, and then what is the business value? But I guess start with the problem, because there's so many good discussion on what problem need to be resolved for each case. And then from there, probably can derive like what's the business value for edge computing.
Yeah, lately I haven't been one of the more active people on that white paper. I'm not sure if we have any of the white paper people on in this meeting today, but I agree with you that would be, either putting it in one of the existing white paper efforts or starting a new one would be worthwhile.
Yeah, just the discussion alone is very valuable. Like all the problem that's been discussed. For example, do they apply to all kinds of edge or just far edge, right? Just those kind of details.
Victor, are you part of the Edge application? Are you contributing to the Edge application document that we're working on at the moment? With
not at this moment, but yeah, I'd be interested.
Yeah, maybe what I can do, if you don't have it already in the notes, Steve, I'll supply a link to it. I'm looking for it now. Okay.
Yeah, and in terms of preserving these discussions, at least I typically cut and paste the stuff out of the chat into the agenda notes document if you ever need to go back. Sometimes it's tough to keep up with the audio, though, particularly if you're talking too much yourself like I usually do.
Okay, here, I'm putting the link in here now for everyone. This is the link to the Edge application, Edge native application design behaviors that we're working on together. Brandon Wick, myself, who's the gentleman from Cisco that's also working with
Joel?
it? We were presenting last week. Joel is on there. Yep. Frank Brockners, etc.
So I thought this meeting was every other week. Is it? It sounds like there was a meeting last week that I missed. Are we actually meeting every week now? Or how's-
No, the reason was we canceled the meeting that conflicted with KubeCon.
Got
So
it.
rather than really cancel it, we just kicked it down the road a week, if you will.
Got it. Yeah.
We debated just canceling it altogether, but I think we wanted to have that OpenZD presentation, so we held one that was sort of out of band.
I see. No problem.
I did notice that even though we canceled it, I get notified when people attempt to join the meeting, and about 3 people missed the notification of cancellation. And I don't know, I was in Amsterdam.
I was one of those.
Okay. There's no good way to handle this in my experience, because if you move it, some
Yeah.
people show up, or some people even remember that it was every 2 weeks. So they'll think I went last week, so the next one's 2 weeks from now. I don't know. There's no, like I say, there's no good way to do it.
Yeah, I've like basically blocked out my calendar with a link to the Google meeting every 2 weeks, and just that's how I kind of keep track of it. So less so keeping my eyes on the Google Doc. And I would like to maybe for the agenda for next week, if we don't already have something. So I have some curiosity questions for this group, and I don't think we have time to talk about them in the next 5 minutes. But one of them is, what's going on with WebAssembly? Where do we stand with that? I feel like there was a hype cycle and a deflation, and it's kind of not sure what's going on. I've been watching some videos and stuff. And then the other one that just is constantly tugging at me is whether or not Kubernetes is the right mechanism for the edge. I think it's got some of the right aspects, but I'd like to have more deeper conversation with people who are in this space about Kubernetes and some of the challenges in general about using container orchestration at the edge.
I would really welcome that. For, you know, I usually put the shell of the agenda up slightly after a meeting ends, so you can't go throw it in there just literally today, but you can nominate those on the Slack channel, and then as a reminder to me to put them in the agenda. How about that? And I'll put them in the agenda for next time.
So
Yeah.
I'm not sure I'm aware of the Slack channel. So what is, I got to get in there. Is it of the same name?
Open the agenda. Do you still have the link to the agenda notes doc? That there's a Slack reference in there at the top, I think.
Okay, let's see. Am I in there?
I just wanted to second Mark's comment. I think that would be a great discussion to have, and to add some fuel to the fire. It might even be a case of maybe Kubernetes is a suitable solution, but maybe it's the orchestration that's not applicable to those far edge devices.
Yeah.
Yeah,
I think so too. You know, Andy, I hate to task you with KCP, but as long as you're doing pass-through that Kubernetes doesn't act on, how about this for, I'm just brainstorming here, but a crazy feature where we put it in there and it gets passed through all these layers, but it's earmarked as this isn't Kubernetes at all, but this Leaf Edge node, let's just throw it out there, is running Docker Compose or Podman in Compose mode. And it's really just a Docker Compose spec. So, you know, there are those who believe that perhaps a Kubernetes, you know, there are people who do a so-called thin Kubernetes that's a single node Kubernetes. And I think there's been plenty of debate on whether single node Kubernetes even is some kind of anachronism. Like, what is it if it's single node? Maybe half of what's in Kubernetes is senseless because it doesn't do anything useful and just brings along a big code footprint that's subject to CVEs and things. And what if this pass-through could even have generic blobs? I mean, to make it really versatile and future-proof, just earmark this as, we don't really know what this is. This is just a blob. Like, just like the OCI container concept was broad enough that it didn't have to be a Docker image, what if what you're forwarding to the leaf node doesn't have to be anything you even have declared you're aware of, but we'll just get it there for you. And that would be a really cool concept that wouldn't lock you into these leaf nodes being Kubernetes, but maybe you could still manage them with the Kubernetes control plane at the top that was scalable.
Yeah, I
So
have
the
some
two-
ideas on that I would love to talk about at another time. Yeah.
Yeah, the view that we have generally speaking is that it shouldn't matter. We believe that Kubernetes is the control plane or the platform you should use for Edge, right? Obviously, I'm a bit biased, but the reason being is that it does afford you the anonymity of the workload or the payload within it, right? So we are looking at things like OCI, we're looking at WASM, right? So this gets two birds with one stone there, Mark. So WASM, the same sort of effect, right? Is that we know that this is lurking, sitting in the background, ultimately will be used by certain providers or vendors to do certain things. I see like the world of printers gets opened up as soon as you include something like WASM, right? I can see that being a tractable technology for them. So just to keep it short, yes on Kubernetes, yes on Ubiquity.
And
And I
Hans,
wanted
we
to go
got
ahead.
Rob and Kate, and we're running out of time. So just jump in and say what you have to say.
Is my mic working? Oh, okay.
Yeah.
Yeah, I wanted to go ahead and jump in on the WebAssembly side. I'm happy to kind of be a liaison for a lot of those conversations, and also wanted to point out there's work underway to create a WebAssembly working group under the runtime tag as well. So that's happening right now. They're building out the charter, and so that's going to be a great place to also ask those questions around how is this evolving and forming. And I'll probably attend those meetings too, so I can kind of bring our questions there that might be specific to what does WebAssembly look like on the edge. And I think the question of also, is Kubernetes made for the edge, is also a question people have around WebAssembly. Is Kubernetes made for WebAssembly? Like, is that the way we want to orchestrate WebAssembly, or are there other orchestrators we want to use and other application paradigms? So I think those two discussions will pair well, just like Andy just mentioned.
Great. Thank you.
Just to be succinct, I'd also be interested in just defining what that leaf node would be and what its capabilities would be, because the worker node brings with it some requirements for having an overlay network and talking to other nodes. And if you're in the medical space and you're making a defibrillator, your defibrillator probably doesn't need to talk to other defibrillators. It's probably quite happy just talking to the hub. So there might be a need for defining a leaf node with fewer requirements for conformance and introducing that into the Kubernetes spec.
Yeah, interesting idea.
Just a quick update on what Rob was mentioning. I think there's a very nice framework called Web of Things. Maybe that might be interesting when it comes to describing what a leaf node is. Maybe it might try to solve a lot of problems, at least for the far edge logics. I don't know. Maybe it might be worth discussing it next time.
Okay, we're 2 minutes after the hour, so I'm going to call this to a close. But thanks everybody for coming, and it sounds like we've got a topic nominated for next time, which is great. We'll cover a couple of things, both WebAssembly and Kubernetes suitability for Edge. Anything else people want to bring up, throw it into the chat, throw it into the Slack channel. Okay, bye everybody. Thanks for coming.
Cheers.